All right, so very good afternoon to everyone. Yeah, Shrisai, very good afternoon. Sorry, the session has started 2 minutes late. Yeah, I hope you can see me and hear me. A very warm welcome to you. Welcome to all the live students. Welcome to everyone who is watching the video. So, I am your physics educator. Okay, I am your physics educator. My name is Dr. Shankar Sir, and these are brief credentials of mine. So let us continue the session with this. So, guys, in the last session we were talking about this thing about the kinematics, and in the last session, in the last video, we have covered till in the last video we have covered till what point we have covered till the average velocity and average speed concept. Okay, so in the last session, we have completed the average speed and average velocity concept. We have solved multiple questions of it. Now, after we study, so in the previous sessions, we have come. So, all the live students, very good afternoon. And I'm sorry that the session has started 2 minutes late. Okay, some technical issue was there. Okay. So in the last video, we have discussed about the average speed and average velocity. We have talked about it. We have understood it. I hope that you have clearly understood the concept of these things. Now, guys, in this session, I'll have to give you some understanding of the basic mathematical tool of differentiation. Because see, we have understood about the speed and velocity. So the next thing we must understood is the instantaneous speed and instantaneous velocity. Instantaneous velocity. Okay. Now, to understand this instantaneous speed and instantaneous velocity, so I told you in the last session there is a basic difference between the average thing and the instantaneous thing is of the time in which we are considering these physical quantities. So when we talk about the average speed or average velocity, basically the time we are considering is big enough. It is a finite time. Okay, like it says that what is the average speed between 0 to 3 seconds. So you have a span of time. Okay, now when I talk about the instantaneous speed of velocity, basically we are keeping the time as constant. That means that like some god we have hold the time. Okay, we have held that time, we are not letting it to move forward. Okay, so when you are seeing the velocity at the instant of time, that is what we call as the instantaneous velocity, and same way instantaneous speed. So the basic difference is that here the time difference we are seeing is dt. And when I use this dt term, this is infinitely small. Okay. Now to understand the concept of this, we will be requiring to understand this dt further. Okay. And for that, we are required to do some differentiation. So, guys, for NEET preparation, what happens is students are very much afraid, sir, how much mathematics is required. So, in this session, I'll be giving you that much differentiation only that is required for your NEET preparation. Okay, not more than that, nothing to be more than that. Just you have to study this much differentiation and you will be good to go. And like in the later topics, whenever some amount of differentiation will be required, we'll read that. Okay, just for the sake of understanding the physics. Okay, so you don't have to read the differentiation as a topic of mathematics. Okay, JEE students have a lot of differentiation to do, a lot of integration to do, but for NEET aspirants the physics level is not that you require very much of differentiation and integration. So I'll give you the differentiation only what you require. Okay, only what you require. Hello Shivesh, good afternoon. So I guess Sri Shai was also waiting, but due to some reason the session has started a bit delayed. I think 2 3 minutes the session was delayed. So I'm really sorry for that. Okay. Okay. So now let's move to some understanding. Okay. Now let's talk about this differentiation. So okay, Sri Shai, yeah. Sorry, you have been waiting. Okay. Sorry for that. Some technical issue happened and I can't do anything about it. So let's come to the point. Now, what is differentiation? Why do we need this first of all? Now, please understand this. Let me give you something. So let's say we have a graph of y versus x. Okay, y versus x. Okay. Now, please understand this. Let's suppose we are having some lines here, some lines here. Okay, like this. One orange, one green, and one yellow, one white. Okay. Now in this, if I ask you which one of them has the highest slope, can you tell me which one of it has the highest slope? Can you tell me that? So yes, sir, you would say that definitely this one has the highest slope, right? The green one. Okay. Please try to understand. This is very important. This discussion is very important. Okay. You may feel that this is somewhat boring, but this is very, very important because lately when we are going to understand, you are going to apply this in the form of, understanding of the graphs, it will be very much important. So it has the lowest slope. It has the lowest slope. So basically, what is differentiation? So if I say like this, so see, this way we understand to see the slope. Okay, a slope basically is a representation that which curve, which curve is having highest steepness. Okay, how much vertical it is. Steepness, you understand, no? See, like the green one is having the highest steepness. So if a curve is having the more slope, that means it is more steeper than the other curve. Okay. Now please understand this. Now please understand this. So when we are seeing the slope of something, please understand this. So this is why this is x. Now, if I want to see the slope, so you can see the slope by the help of this tan theta. Remember, not theta, but the tan theta. So for any curve, the tan theta of the curve gives the slope of that curve. Tan theta of this curve is going to give you audio slope. Just a bit. Okay. I think there must be. Hello. Yeah. I'll just do one thing. Yeah, I hope it would be fine now. Better? Yeah? Or shall I use the. Yeah, I think it would be better because see, my sound, I am using the mic. Even if I speak like this also, my speaking louder doesn't make any difference there. Okay. So I'll try. I have done some changes in the settings, so I think it would be better. Okay. So now talking about the slope. So basically the slope of a curve is given by theta. Okay. By, you can see it by the theta, but the slope exactly is given by the tan theta. It's slope exactly given by the tan theta. Now one very important observation. Now if you see the theta here, if you see the theta at any of the point on this straight line, you are going to get the same theta, right? Do you agree? Do you agree? See, these small information we are going to use later very extensively. Okay, so just listen to each and everything. So here, each of this theta at any point on this line, if I observe this theta, it is going to remain the same. So can I say that here for this straight line, this is constant, right? So one takeaway point from here. So if a curve is a straight line, if a curve is a straight line, its slope is constant. Okay, its slope is constant. Okay, all right. Okay, so do remember this. Okay, and compared to this one, if the slope, if some curve is more steeper, it is having more theta, then that will have the more slope. Okay, now this is one observation. Now we want to get this tan theta. So how we can get this tan theta? Please try to understand this. So let's suppose we are again having this yx. Okay. Now each of the information, if you have any of the problem in any of the observation, then please tell me. Now, if I consider 2 points here, let it be 1 and let it be 2, and the coordinates of this point is going to be x1, y1, and this is going to be x2, y2. Okay. Now, I hope we understand that what is x1 and what is y1. So, what is this x1 and y1? So, this distance is y1. Okay, so when we are measuring the coordinate with respect to the parallel to the y-axis, we call it y1, and this is going to be x1. Now, similarly, this is going to be y2, this is going to be y2, and this is going to be x2. Now, if I ask you that what is the slope of this thing, so can I take theta here? Because this theta is also this theta, right? Now here, if we observe, so we have a triangle here. If we observe, we have a triangle here, and we very well know, because when we were small kids, we have studied this trigonometric thing ना. हम जब छोटे बच्चे थे तो पढ़ा है ना, tan theta, cos theta, sin theta. Okay, in my school it used to say like always a rhyme to it ना. Like I went to a very Hindi medium school, so there was a rhyme, Pandit Badri Prasad Har Har Bole. Okay, okay, Pandit Badri Prasad Har Har Bole. So PBP, Pandit Badri Prasad Har Har Bole. Right. So I hope everyone knows it, right? So P upon H is sine, B upon H is cos, and P upon B is tan theta. So basically, we know that tan theta is equal to perpendicular upon base. Right. Now, if I see to this triangle that is having this one, two, this one, right, this one, right. So now in this triangle, if I see, so I can say that such as tan theta. So what is perpendicular? So this is y2 from origin. The vertical distance to point 2 is y2. From origin, the vertical distance is 2.1 is y1. So this is going to be y2 minus y1. This is going to be y2 minus y1, right? So perpendicular is y2 minus y1, and similarly this is x2, this is x1, so the base is x2 minus x1. So basically when I try to see the slope of a curve, it is going to be tan theta, and it is also equal to y2 minus y1 upon x2 minus x1. Do you agree to it? Is it fine to everyone? Please answer me. I hope it is clear to everyone. Yeah? Okay. Right? Give me a yes. Okay. I hope it is fine to everyone. Okay. So tell me if I am moving very fast, no? Okay. Whenever it seems that you are moving very fast or slow, please do let me know. Okay. I'll improvise. Okay. So this is fine. Okay. Wonderful. So we already knew it. Now the problem is, so if I make a curve like this, so we are interested in knowing the slope of this curve as well. Now, sir, when it was a straight line, right away we could see the theta. But for a curve, how we are going to see? So for the curve, what we are going to do, or what we must do, sir, we must. So if you want to, let's suppose we are having some points here. Now, if you want to see the slope of the curve, so you have to first of all see it at different points. Why so? Because see, when you want to see the slope, you have to make the tangent. Okay, then theta. This is theta, always measured from the x-axis in this cell, in the anti-clockwise sense. So if I take tangent, so what is tangent? We all know the tangent, no? Exactly adjacent to the curve, right? Okay, like this here. Okay, so this is somewhat tangent to it. Okay, so let's call it theta 1. This is going to be theta 2. Now this is, so if I make a tangent here, so this is going to be theta 3. Okay, now please understand this very very important point. So in the curve, so if the curve in xy is a straight line, that the slope is constant everywhere. But when it is a curve like this, or any curve for that matter, the slope changes at each and every point. That means the slope is not constant. Do you understand this? So slope is not constant. Okay, in any curve, the slope is not constant. Okay, but we want to understand. We want to evaluate the slope. So what is the reason we want to know the slope? Okay, Now please understand this. So basically in the last session, we have understood that velocity or speed is change in velocity. Let's talk about velocity. Velocity is change in displacement upon change in time, right? Change in displacement upon change in time. So here, if you see y2 minus y1 upon x2 minus x1, it is somewhat the change of y with respect to the changes in x, isn't it? Okay. So basically, when you are dealing in physics, when you are dealing in the physics, there are several relationships between physical quantities. We all know that the displacement and time is somewhat related. Now, you always want to know that if displacement is changing in this way, what would be the changes in velocity? What would be the changes in acceleration? So, for that, you are requiring to know the slope of the curves. Okay, because slope gives you a right away insight that what is going to happen to the velocity for given changes in something. Okay, are you getting my point? So that is why slope is important. Now here the slope is not constant. So what to do now? Slope is not constant, but we want to evaluate the slope. Okay, so now the problem is, let's realize the problem further. Now please understand this. So this is x, this is y. Okay, this is the curve. So, sir, in the case of a straight line, what we did, sir, we took 1.1 here, we took 1.2 here, and we did y2 minus y1 and x2 minus x1 thing, and we got the slope. But what is the problem here? What is the problem here? So, here the problem is the slope of 1 and 2 are different. Okay, now in this case, when in the straight line you use this concept, so basically the slope of point 1 and 2 were the same. So we use this. So wherever, in this case, realize wherever you take the point 1 and 2, you can take the point 1 and origin 2 at somewhere else. Okay. Okay. You can shift these 2 points. You can make more distance between 2 points. Always you are getting the same slope. But in this case, since 1 and 2 slope is not the same, since 1 and 2 slope is not the same, okay, what is going to happen? You cannot apply this rate directly, right? Do you realize this? First of all, please answer me. Do you realize this or not? Yes or no? See, in physics, understanding the problem is also very important. Okay, unless you understand the problem completely, you will not be able to solve it. Okay, so this is the problem. Now, 1 and 2 has different slope. Now, please think in one way. So this 2 point, I did something and I am bringing it very, very close to this 1 point. What I have done? Now this 2 point, I have taken this point very, very close to point 1. Okay. Okay. In a way that the distance or the difference between this point 1 and 2 become infinitely small. Infinitely small. So that means the slope of these 2 points become the same. Okay. Okay. Right. What we have done, sir, we have brought point 2 very, very close to point 1. Now, when we have brought these 2 points very, very close to each other, then what happens? The slope of these 2 points become the same. Now, when the slope of these 2 points become the same, can I write tan theta? So, tan theta is equal to perpendicular upon base, perpendicular upon base. Now, if I magnify this thing, if I give this some magnification, so when I give this some magnification, so this is point 1, this is point 2 again, but this distance I would write here dy, and this distance I would write here dx. dx. Why sir you are writing dy and dx here? Because when we use this term dy and dx, that means that the distance is infinitely slow. Are you getting my point? Okay, so again using the same formula, this tan theta is going to become dy by dx, and this is the reason why you say that differentiation, that is dy by dx, gives the slope of a curve. Okay, so when you do, you must have heard this, that differentiation is the slope of the curve. So this is the reason why the differentiation is the slope of the curve. Are you getting my point? So when 1 and 2 are distant enough, you need not to do this. If it is a straight line, But if they are if the slope is different, then how you write this? So you bring them together, you bring them very close to each other, and then you can say that the slope is dy by dx. So what is the ultimate thing? Shivish, are you there? And Bima, Bida, are you getting something? Yeah, I think you are new to the class. So for a slope of a curve, for a slope of a curve, we must do differentiation. We must do differentiation. शिवेश आप हैं बेटा क्लास में right? So भैया when we are doing differentiation, that means that we are finding the slope of that curve. Okay, now for example, if we do ds by dt, so basically it is the slope of s and t curve. Okay, and this is lately we are going to understand that this is going to be the velocity. I'll come to that, but before that let me tell you some basic mechanism of differentiation. Okay, basic mechanism of differentiation. So I'll be giving you some formulas. Okay, okay, so you are going to use it in finding the velocity, you are going to use it in finding the acceleration, but let us understand some mathematics of it. So for this you must be requiring some formulas. Okay, yeah, she said. Okay, so we will be requiring some formulas. So what formulas will be required? So the first one is d by dx of x to the power n. D by dx of x to the power n is equal to nx n minus 1. So you need to memorize all these formulas. Okay, these are very useful, very much used. Okay, okay. Uh, Secondly, so first I must tell this one. Let's suppose d by dx. Okay, d by dx. So I'll write like this. So let's suppose y is equal to 5. Okay, this way we are moving forward. You will see the question in kinematic this way only. Okay, so let's suppose y is equal to 5. Now, if y is equal to 5, what is going to be the dy by dx? So it is going to be 0. It is going to be 0. So remember, the differentiation of any constant, it can it be 5, it can be 1, it can be 2, it can be pi, it can be anything. So if anything is constant, when you differentiate it, you are going to get 0. Okay. So we didn't realize it. So see, every time it is not possible to make you realize everything, and that is not necessary also. But if you see, so it is a constant. So if you plot this curve in this graph, you are going to get like this, a straight line. Okay, right? Yeah. Now, what is the slope of this curve, sir? So from here, the curve also we can see that the slope is 0, right? The slope is 0, isn't it? Isn't it? So, sir, here the dy by dx is going to become what? It is going to become 0, right? Okay. Now, the second formula. So, when we are differentiating, first concept, first formula, when we are differentiating any particular constant, we are going to get the 0. Now, let's suppose y is equal to x to the power n. So, what is going to be dy by dx? Okay. So, this is very important. Nx n minus 1. Remember this formula. So, when you are differentiating this x to the power n, we are getting nx n minus 1. Okay, nx n minus 1. Okay, very useful. So sir, if we want to differentiate, let's suppose y is equal to x. Okay, if we want to differentiate y is equal to x to the power 5, if we want to differentiate y is equal to root over x. Okay, so what is going to be the solution here? Just you have to use this formula, right? Y is equal to x. So y is equal to x to the power 1. So dy by dx is going to be 1 x 1 minus 1. Okay. So it is going to be 1 only. Right. Okay. Differential of x is 1. Now x to the power 5. So what is going to be dy by dx? So compare from here. So x to the power 5. So nx n minus 1. So 5x n minus 1, that is 5 minus 1, 4. And also guys, I am not expecting, if you already know this formula, that is very well. If you don't know it till now, I am not expecting you to memorize this in one day. It will happen with time. You have to keep doing some practices. You have to see it once or twice, and then it will be memorized. Okay, but you have to anyway have to memorize this basic formulas. Okay, yeah. Now this y is equal to root x, so it is going to be dy by dx. Now compare from here, so sir, it is x to the power 1 by 2. So n is 1 by 2, so this will become 1 by 2, x to the power 1 by 2 minus 1, so that is minus 1 by 2, right? Okay, very simple, very simple, sir. Very simple. Now, now, so this is also you can write as a formula. This is also used a lot. So if y is equal to x, then dy by dx is equal to how much? So it is equal to 1. Okay. Now if y is equal to 8x, let's suppose y is equal to 8x. Now in this case, if you write dy by dx, it will become how much? So it will become 8. Okay. How, sir? How? So 8 is the constant, you keep it outside, then you have dy by dx, so that is d by dx of x, so it is going to be 1, right? Okay, so you are getting the way. Now let's move to some more formula. So if y is equal to e to the power x, okay, exponential function. So when I differentiate it, I'll be getting dy by dx is equal to e to the power x. So when exponential function is differentiated, it is not going to change. Okay, so dy by dx will become e to the power x. Okay, e to the power x. Now we have, let's suppose y is equal to log of x. So log base e of x. So in this case, dy by dx is equal to going to be 1 by x. Wonderful. Okay. Now let's move to the sixth formula. Okay. So the other live students, please feel free to ask me anything. Right. So if y is equal to a to the power x, then dy by dx. So some of it might not be used to you, but see, this basic formulas you must know according to me. Okay. All these are very basic formulas, so you must be knowing all these. Okay. Okay. So a to the power x, so this will become like this. So now we have if y is equal to sine x, okay, then we have dy by dx is equal to, it is equal to cos x. Okay, it is equal to cos x. So differentiation of sine will become cos. Okay. Okay. Now if y is equal to cos x, so dy by dx. So I'm just writing this formula. So dy by dx will become dy by dx of cos x, that is minus of sine x. Okay, minus of sine x. Now if y is equal to tan x. Okay, what is going to be dy by dx, guys? So when you differentiate this tan, you will be getting sec square x. Okay, yeah. Okay, sec square x. Now let's suppose we are having y is equal to sec x. So I'm giving you just the basic formulas. Okay, after we'll do some algebra of this also. Now dy by dx is equal to, so sec x, so this is going to be how much? Sec x tan x. Okay, these basics, only basic formula. Now if you see y is equal to cosec x, okay, so dy by dx, okay, so please observe the pattern also. Now see, whenever you are, so see, this can be, I used to remember it this way. So if when you differentiate any quantity, any trigonometric ratio starting from C, you will be getting the negative sign. Okay, like for example, when you were differentiating y is equal to cos x, you are getting minus sin x. Now similarly, y is equal to cosec x is equal to minus cosec x and cot x. Understood, beta? Okay. Okay. Now, similarly, see, when you have this y is equal to cot x, okay, then dy by dx is equal to minus of cosec square x. Okay, you are getting the minus sign, right? Okay. Okay. Now, similarly, so we have done this. Okay, so I hope you have understood it. So these basic, only these basic formulas I hope are required. If anywhere I will see in any question some more thing is required, we'll improvise them. Right? Will that be fine? Now please understand this. So let's suppose y is equal to x square. So dy by dt will be, what will be dy by dt then? If y is equal to x square, what is going to be dy by dt? Can you tell me? Shivesh, yes, beta, you have to memorize all these. Okay. See, if you don't want to memorize all this, at least memorize this one. Okay. See, you understand this one now? Yeah. X to the power n, very simple one. Okay. Now this is an extension to it. So at least memorize this one, this one, this one, this one, and this one. At least. And if you can memorize all these, that is the best thing, right? But at least memorize these. Okay. Because see, the whole see physics, mathematics, I'll tell you something. Why mathematics was developed in this world? To understand the physics. Okay, so mathematics has the role, it is a helping hand to physics. Otherwise, mathematics has no purpose at all. That is why mathematics subject is considered as a tool. Are you getting my point? So at least memorize these. Okay, and if at all you can memorize everything, then it is okay. So what is the answer to it? So Shisa, you firstly said 2x. Okay. So you cannot say anything actually at with this much information because you don't know if x and t have some relation amongst them. Okay. Okay. Otherwise you cannot say. Okay. Now if we consider now in this if what we can say if x and t have no relation, they are unrelated. If they have no relation, this is something which is very much necessary to mention. So let's suppose if we are supposing that x and t has no relation, so it is going to be 0. Okay, because if see here when you are differentiating, so when we memorizing the formula, also we must understand is that with respect to whom we are differentiating the quantity. Okay, so this is x square. If this is differentiated with respect to x, then it will become 2x. But here it is getting differentiated with respect to t. So if t and x has no relation, you can consider x as somewhat constant with respect to t. Right? So we are going to get dy by dt is equal to 0 in this case. Right? So remember to see that you are differentiating in respect to what? In respect to means like it is written dy by dt. So how we read it? We say that the differentiation of y with respect to t. Okay. Now let's understand some algebra of differentiation. थोड़ा सा algebra भी समझेंगे. Algebra of differentiation. Okay. What do we mean by algebra? In general, what is the meaning of algebra? Yeah. So, sir, algebra means, sir, addition, it means subtraction, it means multiplication, it means division. So, algebra of anything is meaning. What is the meaning of algebra of anything? That means, sir, we need to add, subtract, multiply, divide, like that. Yes or no? Do you agree? Yes, sir. Now we are going to see like this. So see, let's suppose we are having a function of y and this y, let's suppose it is equal to x square plus 5x plus c. Okay. Now I want to differentiate it with respect to x. Okay. With respect to x. So when I want to differentiate it with respect to x, how I am going to differentiate it? So all you have to do is differentiate each of these terms individually. You must differentiate each of this term individually. So what do you have to do? So one way you can write dy by dx equal to d by dx. So this is the first and the last time I'm doing like this. D by dx of 5x. Okay, Shivesh, you want me to go down? Go slow. Please tell me, beta. If you want me to go slow, that is fine. Okay. So what happens? You want to differentiate this function. So you just let this d by dx go inside this function. Okay. Yes. Okay. So what it is going to be? So d by dx of x square. So what is the formula? X to the power n. कौन सा फॉर्मूला लग जाएगा? x to the power n. So it will become n x n minus 1. So n is 2, x n minus 1, that is 2 minus 1, that is 1. Now dy dx of 5x. So here 5 is constant, you can bring it outside, and what is the differentiation of x? So it is going to become 1, and d by dx of 6. So this is a constant. When constant is differentiated, this is 0. So ultimately we are getting dy by dx is equal to 2x plus 5. dy by dx is equal to 2x plus 5. I hope it is fine to everyone. Yeah, please answer me. Shivesh. Well, let's suppose we have and this is cosec x. Just let's do this question. Please do it. Let's try this one. Very, very simple. All you have to do, you have to differentiate each term of this expression. That will be all. Nothing much. Please try. Yeah. So very simply, if you know the formula, you could do. Okay. Okay, Shivesh, are you trying, my dear? Or anyone, any other the live student? Any other live student, beta, who want to say something? Yeah. So we have y is equal to x cube plus e to the power x plus log x plus cosec x. Okay. Now what we can do, sir? So we want to know dy by dx. Okay. Now you take d by dx for inside this. Okay. You differentiate each of this term separately. So d by dx of x cube, this will become 3x square. D by dx of e to the power x, it is e to the power x. D by dx of log base e to x, so this is 1 by x. What is this cosec x? So minus, what is the differentiation of cosec x? So it is minus cosec x and cot x, right? Very, very simple, isn't it? Isn't it? Now let's move further. So I want to know if you are understanding this. Shweta, you are understanding it. Very good. Shivesh, what about you, my dear? See, I hope you understand. You are not cursing me for this, now. You try to understand this that I am just interpreting this physics. This is made by someone else. Okay, so don't curse me. अरे सर ये सब फॉर्मूला याद करना पड़ेगा, अब क्या होगा, है ना? We need to memorize all this formula. So it is not that, it is not that difficult. Okay, it is not that difficult. See, with questions you memorize. So even the math students are doing the same thing. I am an engineer, na? Okay. So I did it with the flow. First day you say it, अरे भाई क्या formula. अभी धीरे धीरे याद होता है. You will be able to memorize it with time. Okay. Don't be in hurry. Now if I try to do like this, let's suppose y is equal to x sine x. Now here there are two functions of x which are multiplied. Okay. Okay, so how you are going to do it? So see, very, very simple. I'll just tell you in one go. See, there are two functions. One is x, one is sine x. Okay. So what you want to do? So dy by dx when you want to find. So you leave one. Okay. So x and sine x. Okay. So there are two functions. Uh, Shri Sai sir, I am too bad at class 12. Sir, can you do two classes each of class 12? She said, I'll talk about it to the team. Okay. See, you understand. See, I am work. See, I'm the one who is very honest about each and everything. So you understand that I am working in an organization, an academy, right? Now there are some guidelines which I need to follow. Are you getting my point? Okay. So in that way, the present guideline is that we have to go as per the syllabus of the NEET unit by unit. I'll be more than happy to start any other topic at the same time. So I'll convey this message to them. And if possible, we'll start with one topic of 12. Okay. Because even I want to do it. Okay. But the thing is that there are some guidelines that we need to follow. Right? Okay. This is I could tell you I can make any promise, but I'm not that kind of a person. Okay. What is there, I must tell you. Right? This is how I am. Right? So now let's focus here. So, sir, we have y is equal to x sine x. Okay. So, see, you are keeping x1, okay, then sine x and sine x. So, there are two, parameters, two functions, x and sine x. So, what you leave one and you differentiate the other. Okay. Then you leave this and you differentiate the other. So, we are getting x cos x plus sine x. Did you get this? Did you get this or not? This is what we call as the UV rule, okay, of differentiation. So let's suppose y is equal to UV. Now please see. So dy by dx, how are we going to write it? So u dv by dx plus v du by dx. Are you getting my point? So see, when two functions are multiplied to each other, what you are going to do, you are going to leave one, differentiate the other, then leave the one which you have differentiated and differentiate the one you have left. Right? Right? इंग्लिश में थोड़ा कॉम्प्लिकेट लग रहा है, हिंदी में बोलो क्या, एक को छोड़ा एक को किया, फिर जिसको छोड़ा था उसको डिफरेंशिएट किया और जिसको डिफरेंशिएट किया था उसको छोड़ दिया. आर यू गेटिंग माय पॉइंट? ठीक है. ठीक है, वेरी वेरी सिंपल. नो. ओके, नाउ ट्राई दिस वन. X square e to the power x. Let's try this one. Please go for it. Please go for it. Let's try this one. I'm very sure we can do it. Same UV method you can apply. Same UV method we can apply. So you have answered something. Okay. Yeah, perfect. So see how we are going to do it. See, very simple. There are two functions. One is x square, one is e to the power x. So dy by dx is going to be, so you are leaving one, differentiating other. Then this one you are leaving and you are differentiating this 2x. You are getting, sorry, you are differentiating this x square. You are getting 2x. Yeah. Huh. Huh. X square. I got that. I got that. Right. Okay. Clear? So this is what we call as the chain rule, right? We can try some more, just for the sake of understanding. Cos x log x, right? This similar UV rule you are going to see in the integration also. Let's try this one. Please try to do this one. Shivesh, what about you, beta? So y is equal to cos x log x. So dy by dx. So what we are going to do? So cos x, leave it, differentiate this one, then leave this one, differentiate this one. Right? Right? Okay? Okay? Very, very simple. Right? Very nice. So we'll be able to deal with it. Now, if I give you somewhat like this, so y is equal to x cube minus, yeah, plus sin x minus x to the power 5 log x. Now, how you are going to do it? How we are going to do it? So very, very simple. So in the same way we are going to do it now. Just give me the answer to it quickly. Very, very simple. So we are having y is equal to x cube plus sin x minus x to the power 5 log x. So first of all, it is in addition. So let's write dy by dx. So it is going to be x cube. So it will be 3x square. Then the differentiation of sin x is going to be cos x minus 5x to the power 4. Now please understand this. So this is the product of 2. This is the product of 2. So we have to apply the UV method. So let's take minus outside and apply the UV method. So UV method, so we are leaving x to the power 5, differentiating log x. Then we are leaving log x and differentiating x to the power 5. That is 5x to the power 4. 5x to the power 4. So you open the bracket, you will be getting whatever is the answer, right? Okay, so 3x square plus cos x minus x to the power 4 minus 5x to the power 4 log x, right? Very, very simple. Yeah, yeah, very simple, no? No problem at all. Now, sir, if there is a function like this, so y is equal to sine x upon x. Okay, so you can do it by UV method also by considering one as sine x, other as 1 by x. But there is one more way of doing it. I'll just give you. So it is said that it is u by v method. So in this, see, very simple. When there is a fraction, so normally this method is used when you are using a bigger differentiation, but just for the sake of informing you, okay, just take it as the information, because you can solve simple question by considering u by v as UV method only. So here you can consider U as sin x and V as 1 by x. That is also good to go. Okay, but let's, for the sake of knowledge, we understand this. So dy by dx, see, U by V. This is also very simple. See, this is V. V square, denominator will become square. This V will go here. If you remember this, rest you will be able to write. Okay, so when you are writing V here, you will have to differentiate the U. Now, since you have differentiated the U, you must keep the U outside the differentiation and you must differentiate them. As simple as that. Okay, U by V method. So in the denominator, you will be getting V square. Then in the numerator, if we have, in the denominator, if we have V, V is squared, and then V goes like this. Okay, okay. So simply how we can do? So if we compare, if we use this formula dy by dx, so it will become v square, v is equal to x, so x square, then x sin x, so du by dx, that is d by dx of sin x, that is going to be cos x, minus u is sin x, and dv by dx, that is going to be 1, right? Will you be able to do these? Yes or no? Please answer me. Let's suppose we have y is equal to x square plus 1, y is equal to x square plus 1 upon x cube. Now, in this case, dy by dx is going to be what it is going to be. Can you answer me? Can you answer me, guys? Anything? 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 Very, very simple. Other students can also respond to me. See, you have to learn this much differentiation for physics of the NEET examination. Very, this much is necessary. Okay, इतना आना चाहिए, otherwise दिक्कत हो जाएगा. Okay, this much you must, you know, remember at least. So how we got to do it, sir? So we can apply u by v method again. So sir, how we are going to write it? So dy by dx is equal to u by v. So v is x cubed. So v square. So it will become x to the power 6. Then we are having v, that is x cubed. So we differentiate x square plus 1. Now when we are differentiating this x square plus 1, we are getting 2x. Then with the minor sign of subtraction, we are leaving the u and we are differentiating the v, that is 3x square. 3x square. Okay, so what we can do, so we can open up the bracket and we can do some mathematical basic algebraic calculation and we'll get the dy by dx, right? Okay, okay, so very simple, so we'll be able to do it. Now there is one more concept in the differentiation that we must know, that is the chain rule. Very simple, very simple. So see, let's suppose we have y is equal to root over x square plus 1. Y is equal to root over x square plus 1. Now in this case, how you are going to differentiate it? So this is what we call as the chain rule. Okay. Now you know the differentiation of x to the power 1 by 2. Okay. So x square plus 1 to the power 1 by 2. So what is going to be the differentiation to it? So see how you are going to do it. So firstly you apply your basic formula. Firstly you apply your basic formula. So root over x square plus 1. So it will become 1 by 2. X square plus 1, 1 by 2 minus 1, that is minus 1 by 2. Okay. Now this x square plus 1, you further differentiate it. So it will become 2x. Are you getting my point? Okay. Are you getting my point? So this is what we call as the chain rule. Are you getting my point? So what is the chain rule? So you are differentiating like the chain. So there is the reaction, nuclear reaction, the chain reaction. One thing leads to another. It moves like a chain. Okay. Okay. So when you are differentiating using your basic formulas, if there is a quantity which is now there is a function which is not exactly in the same way as you have learned, so you can apply the chain. That means you can apply those formulas again and again and again and again, right? Okay. So what we have done, so it was root x square plus 1. So I have considered, so there can be a long way to it also. So consider x square plus 1 as y, then differentiate that. So we are not going to do that. We are going to take it simply. Now let's try this one. Let's suppose y is equal to e to the power 4x. Okay. Now what you are going to do? So sir, e to the power 4x, we know the differentiation of e to the power x. So we know the differentiation of e to the power x. So we will do the differentiation of e to the power x only. Okay. So what is going to be the dy by dx? So it is going to be dy by dx is equal to e to the power 4x. Now this 4x is not x, so we need to differentiate it also. So moving in the chain, so now differentiating this 4x, we are getting 4. So it will become 4 e to the power x. Okay, like for example, if we have y is equal to, let's suppose, sine x square. Okay, now how we are going to differentiate it? So we understand that the differentiation of sine is cos, so we'll write cos x square, then differentiate this x square too. So it will become 2x, right? Okay, it will become 2x. Understood? Understood? Let's suppose y is equal to, let's suppose, just a moment, yeah. Let's suppose y is equal to cos of x square plus 2x plus x e to the power x. Now how you got to do it? How you got to do it? Can you tell me how we are going to do it? So very simple, sir. We are going to apply the chain rule. Okay. How we are going to apply the chain rule? So sir, dy by dx. Huh. No. Just very simple. It is same. It is not complex. It is not at all complex. The same way I am doing it. Just see. We know the differentiation of cos, so it will become minus sine x square plus 2x plus x e to the power x. Okay. Now this is not x, so you need to differentiate it. Now differentiate it also. So x square will become 2x, 2x will become 2, and x e to the power x. So x e to the power x plus e to the power x. Isn't it? You apply UV method to this. Same way, same way. Isn't it? Please answer me. Okay. This is why it is called as chain. Okay. Differentiation after differentiation after differentiation after differentiation. Are you getting my point? Right? Okay. Very simple, isn't it? Okay. Very good. Very good. So, guys, at least this much differentiation basics you must know for your NEET preparation. See, this is what NEET aspirants make a mistake there. Na? See, in many concepts, you will be requiring to do some differentiation, some integration. Are you getting my point? No problem, no problem. Please, I understand, I understand. Okay. So, guys, NEET aspirants has this illusion that the mathematics, we are a biology students and we must not know differentiation integration. I tell you one thing very frankly, that just ask the pain of JEE aspirants. They are reading this much in this much depth now. In differentiation integration, the whole mathematics revolves around it. Okay. But sir, for us, this much is sufficient. You don't have to read any more differentiation. Are you getting my point? In some concept, we'll be requiring to use some differentiation. So if you allow me, can I tell you one more thing that is very useful in physics at times and in solving many tricky problems also. Just one more thing. Just one more thing. I'll just take it briefly and then we'll move to the kinematics in this session only. Okay, I'll tell you some, we'll solve some, we will take the kinematics further so that we can see that where immediately this differentiation concept we have learned can be applied in the field of physics. Okay, so application of the derivatives. Okay, this is what we call as the derivatives. Okay, so what is the derivatives? So x to the power n, if we differentiate it, it will be nxn minus 1. So nxn minus 1 is the derivative to x to the power n, right? Now, what is the application? What is the application to it? So, see, whenever, see, it is very, so see, curiosity. So, see, these lawmakers, that means the physicists, those who have, given this world the beautiful physics, right? Now, they were always very curious. Okay, so whenever you are trying to evolve with some physical quantity, most of the time we are very interested in knowing the peaks of that physical. Peaks means the minimum and the maximum value of that physical quantity. Okay, so for getting the or for understanding the maximum and minimum value and the condition at which this maximum and minimum value arrives, you you can use some concept that you have taken from the derivative. Okay. Okay, now please understand this. Let's suppose there is a curve. Let's suppose there is a curve. Okay. Okay, now this curve is like this. Let's suppose this is a curve like this and there is a curve like this. Okay, there is a curve like this. Now, can you see from the curve that this is the maximum point and this is the minimum point? Do you agree? From this simple curve, this is the maximum, this is the minimum point in both these curves. Yeah, obviously, so from the curve we can clearly see. Now, if you see, sir, if I want to see the slope of the curve at any point, I want to see it through the help of the tangent. So when I see it through the help from the help of the tangent, so this is going to be 0 degree. Can you realize that the slope of these two points is 0 because I have made the tangent to it and the tangent is parallel to x-axis. So now slope, sir, what is slope? So slope is dy by dx. Now, when a slope is dy by dx, can you realize that when dy by dx is 0, this dy by dx is 0, this function y. So let's suppose y is the function of your x. And this function you have given dy by dx. So when this dy by dx is 0, that means the slope is 0. This curve or this function may attain either its maximum mark or maximum value, or its minimum mark or minimum value. Now, what is the use to it? So see, just keeping it very, very concrete, very, very concise, in any of the physics chapter, please listen to me, in any of the physics chapter, whenever you see this word, that's the, what is the maximum of this physical quantity? Okay, at what condition this physical quantity becomes maximum or something like that, becomes minimum? At what point, at what coordinates, at what system? Always do this thing, that differentiate that with respect to x and put it equal to 0. Put it equal to 0. Are you getting my point? Are you getting my point? Okay, like what is the maximum power that can be transferred? What can be the maximum torque in future? So in all these things, you have to do this thing, dy by dx is equal to 0. Is that fine? Okay. Okay. Now, when you do dy by dx is equal to 0, when you do dy by dx is equal to 0, you now know that the value of y, will be 0, will be maximum or minimum. Now, how you are going to know that when the value of it is going to be maximum or is going to be minimum? So for that, so see, when you do it, you are going to get some point. Okay, you are going to get some values of x. Okay, now you put this value of x in d2y by dx square. What is d2y by dx square, sir? So it is d by dx of dy by dx. अरे सर हम बायो के स्टूडेंट, अरे भाई don't worry at all यार, इतना पता होना चाहिए. You must know at least this much. Are you getting my point? Are you getting my point? Don't get so afraid, है ना? Right? So d2y by dx square, so it is equal to d by dx of dy by dx. Are you getting my point? So see, there is a function. Let's suppose there is a function y is equal to x cube. Yes, Shrishai. This is very important concept. I'll show you the use of it in future classes. So y is equal to x cube. So dy by dx is equal to 3x square, right? Now, if you differentiate this function again, you are going to get d2y dx square is equal to 6x. Okay, 6x, right? Now, if you put it equal to 0, so like this is just one example. Okay, not every function has to be maximum or minimum. Okay, sometimes it is not applicable. But in this case, let's suppose in this case, so how to get d2y by dx square? So when you put dy by dx is equal to 0, you may get some values of x. You may get some value of x. Okay. Now, when you get some value of x, you can put this into this thing. Okay. You are going to get something in d2y by dx square. So when you put this x in this d2y by dx square, you can get positive value or you can get negative value. So when you put the values of x here and you are getting positive, that means the function is minimum. Okay, that means y is minimum, and if you are getting negative, that means y is maximum. Are you getting my point? Are you getting my point? Okay, so first thing, okay, when you why we double integrate, double differentiate. So this is the very use. Also, sir, it has more uses, but whether you have to go there, that is questionable. Like, sir, in this question, sir, why I stopped? Because if you put dy by dx is equal to 0, so you are getting x is equal to 0. Now you put x is equal to 0 in d2y. When you put this x is equal to 0, in d2y by dx square, you are getting 0. That means you are not getting positive and negative. Okay. When you are not getting positive and negative, you have to differentiate again. And if the value is non-zero, that means it is a point of inflection. Now, what is the point of inflection? That is, into this step you must not do, being a NEET aspirant. Are you getting my point? Right? Okay. So double differentiation has some use here, right? Okay. So you don't know. See, there are so many things there. Okay. Clear? Okay. So like simply, if we let's say y is equal to x cube minus x square minus 6x plus 6, right? Like this. Okay. Let's suppose this is a function. Now, this function, this can be a function of displacement. Now, you please think this way. Let's try to apply this concept in physics. Mathematics is a tool which helps you understand more of physics. Are you getting my point? That is the only use of mathematics in this world. Now, please understand this. And rather than those uses that we do daily, no, कि सर 100 रुपए का कुछ खरीदा तो 500 का नोट दिया तो 400 वापस मिलेगा. That is one different mathematics. But when we talk about the mathematics of differentiation and integration and this high level mathematics, that is basically used to understand the physics. Okay, sometimes the statements when I make like this, okay, some mathematics teachers are getting angry here why he's saying so, right? So please listen to me. No offense to anyone, but basically this is the fact. So x cube minus x square minus 6 plus minus 6 plus 6. Okay. So it could be an equation of displacement. It could be an equation of velocity. It could be an equation of acceleration. Right. Now please understand this. Now what is going to happen? So we want to know at what point this, let's suppose this velocity is going to be this is a function of displacement which is going to be a function of time. Let's suppose. Now you want to know at what point the displacement, at what time this displacement is going to be maximum. Okay. Do you want to know it or not? When something is in motion, are you interested in knowing that at what point it may have the maximum displacement, or it may have the maximum velocity, or it may have the maximum acceleration? Do you feel that there is a need of knowing this? Isn't it? Yes, sir, definitely. When we are analyzing something, we want to know what are its maximum value. Oh, Harsh sir class is there, na? I'll just leave you. I just leave you. After this, I'll leave. Just this last concept. I just forgot it. I was going to take it further for because last day you guys only said na that at least take 2 hours. Now you are saying that leave the class. Okay. I'll request us to. Uh, Chalo, chalo, it's okay. I'll leave you. I'll leave you today. Don't worry. I'll leave you. Okay. Just last concept. So y is equal to x cube minus x square minus 6x plus 6. So in this case, when we differentiate it, so dy by dx, we are getting 3x square minus 2x minus 6, right? Okay. Now we want to know its maximum value. So we want to put it equal to 0. Whenever you want to know the maximum minimum, you put it equal to 0. So now this becomes a quadratic equation. Now, do you know that any quadratic equation have two roots? Yes or no? Please answer me. Right? Okay. So let's suppose you get two roots. So see, I'm not going to solve this. Don't worry. Let's say you get A and B, two values, two any random values, you get A and B. Sir, we can use, sir, we know now how to get the roots minus B plus minus under root B square minus 4AC upon 2A. Sridharacharya rule. 10वीं में 10th में पढ़ा ना हमने. Okay, or we can do otherwise also, but this is the most easiest if you remember the formula, finding the roots. Okay, when you go into the simple harmonic motion, damp vibration, damp oscillation, so in that also you will be requiring to do this. Are you getting my point? So you got the root, let's not do the calculation. A and B we got. Now we can find d2y by dx square. So it is going to be 6x minus 2, right? ठीक है जी, मैं she requested the. Okay, so d2y by dx square, it is going to be 6x minus 2, right? It is going to be 6x minus 2. Now when you put the value of a here, you may get positive or you may get negative, right? If you put value of a here, you may get positive or negative, and likewise when you put value of b here, you can get positive or negative, right? So if you get positive, If you put A, you get positive. That means that at this A value, this is going to be, you know this formula na? From the famous trick. Very good. So this is positive. So if you put any value of x and you are getting a positive, if you are getting d2y by dx square as positive, that means that at this value of x, the function is minimum. If you are getting d2y by dx square as positive, the function is minimum. And if you are getting, when you are putting the value of some x and you are getting d2y by dx square as negative, okay, that means at that point that is going to observe the maximum value. Is it fine? Now there is some more uses to it. Just 2 minutes more. You asked me the more this stuff. So you must have seen that the displacement is a function of time, right? Displacement in a function of time. And when I differentiate this, so I'll be coming up with this in the next session also. So when we differentiate the displacement with respect to time, we get the velocity. Now, when you differentiate the velocity, you get the acceleration, right? Okay, so acceleration is written this way, dv by dt, and acceleration is also written this way, d2s by dt square. Okay, because if you put v is equal to ds by dt, it is getting d2s by dt square. So Shri Sai, basically what I'm trying to tell you, so the second derivative also have some uses. Are you getting my point? In understanding some physical quantity, you may require to differentiate some physical quantity twice with respect to something. Are you getting my point? Like for example, if you double differentiate the velocity with respect to time, you will be getting jerk. Are you getting my point? Jerk. Right? Okay, so it is having a lot of use. So guys, in this session, what we have done, I'll be keeping it to this point because you are having the next session. So guys, in this session, we have understood the use of differentiation in kinematics and physics, and this much differentiation is more than sufficient for all the NEET aspirants. Okay, so in the next session, we'll be seeing the applications to this in kinematics. So till then, thank you very much. Have a good day, and please go to the next class, and also please refer to your students also to come to the channel and subscribe it. And I hope you guys already have subscribed. Okay, so with this, thank you very much. Have a good day, and we'll see you in the next session again.